Okay, so in this video, we are going to talk about bonds. That's a module 4, and we are going in detail about how to calculate the price of bond um, and then the various aspects of bond under the actuarial exam FM. So let's go to the bonds. So we are going to talk about bond valuation. So what is a bond? A bond is a security. Security is a financial instrument that has monetary value and can be traded. So bond is a security issued by government, entity or corporation that promise certain payment at future dates. So that's something you need to remember. So they are promising payments at future date. So the bond buyer would make a payment right now, and the government entity or corporation, or for example, U.S. government or state municipal councils or big corporations, they can issue bonds, and then they would promise certain payments at future dates. But you have to buy the bond, so that you have to make the payment right now. So you are making the payment right now. Then the other side, the bond issuer, is going to pay back it in future dates. So the term of the bond is the length of time from the date of issue until the date of final payment. The date of the final payment is called the maturity date or redemption date. So these terms you need to remember: maturity date or redemption date, and then the term, and there are some other words. So you need to remember these words when we are going to do mathematical problems. If the maturity date is fixed, then those bonds are called non-callable. And then there are some bonds you can that can be called date prior to the maturity date, and these are called as callable bonds. And then you may have bonds with indefinite, infinite term, and these are called the perpetuals. So we learn about perpetuities. In the annuity, so the same way you can have bonds with infinite term. So here more terms we use in under the bonds. A bond promise only single payment at the end of the maturity date, then those are called zero coupon bond. So this means the only one payment at the end of the maturity, at the end of the term. So those are zero coupon. And then you have coupon bonds, which usually pay periodic payments, which we call as coupons until its redemption. So the example is like 6 month coupon bonds. So you usually then that means you will get coupon amount at every 6 months. The rate used to calculate interest payment in coupon bond is called the coupon rate. So this is not the market interest rate. This is a specific fixed rate. It can be actually floating rate, but it is a rate defined in the bond prospect, and it will define, okay, this is the rate we are going to use to calculate the coupon amount. And the face value or par value is the bond of a bond is the number used to calculate the size of coupon payment. The redemption amount is the amount that the bondholder receives at the bond maturity date, excluding the coupon payment. Now the face value may not same as redemption amount. Okay? So these may be two different values. Usually they are same, but there's no rule saying it should be same. Okay? It can be different. If the redemption amount is same as face value, then bond is said to be par value bond or to be redeemable at par. If no redemption amount is specified, then we assume the bond is par value bond. Now that is something you need to remember when you're doing problems. Okay, so if no redemption amount is specified, then you think the face value is same as redemption amount. Here you can see more notations. So N is basically number of years in the bond term. M is number of coupons per year. Alpha is coupon rate. Or usually we use R actually, coupon rate. Alpha is nominal coupon rate. And the R is coupon rate per coupon period. Then you have G, modified coupon rate. We will learn about that rate. You have yield rate, nominal yield rate, effective yield rate. So you have two different notations. and annual effective yield rate. So J is actually an effective yield rate for coupon period, and I is annual effective rate. And you have face value, redemption amount, base amount, price at issue, and the present value of the redemption amount. Okay, so these quantities you need to remember when you're doing problems. Now, there are 4 formulas which you can use to calculate bond price. So these are the basic price formula, premium discount formula, base amount formula, and the McHam formula. So we are going to learn each formula. Actually, all these 4 formula connected to each other. So starting from one formula, you can derive the other 4, other 3. So we are going to learn about this formula as well. So basic price formula. So let's think about the bond. So what's going to happen? So this is the timeline. Okay. So let's say you have n coupons. Okay, so this is the 0. This is where you issue the bond. Bond issue in agency. So this is the bond issuance. Then you have coupons. Let's say it's n coupons, and then here you get the redemption amount. So here, this is the point where buyer P to buy the bond, and then you will have these coupons. So let's say this is coupon, this is coupon, and here you also have coupon, but plus redemption amount. Okay, so the last one you have the redemption amount too. So of course, you can derive the price using present value formula. Okay, so price should be what? Present value of all these coupon. No? So when you take present value of coupon and the discount rate, this one V, this one V square, and then this coupon is V to the N. Okay, so present value of coupons plus you have to take the present value of redemption amount. So present value of redemption amount. Now that should match to the price you paid. Okay. So this is the basic price formula. So that's what you will see in this first line. Okay. It's very intuitive. So your price you paid by the bond, that should match to the present value of coupons plus present value of redemption amount. Now the question would be this discounting. Okay, so in order to get the present value, you have to use this V, no? So what is V? V is basically 1 or 1 plus I. Now what is I? I is basically effective interest rate per coupon period, no? Now you are the one who deciding what rate you are going to use. Okay, so this is depend on the investor. Okay. So there's no universal rate you can use. Okay, so let's say in the market you will see like rate 7%, then you can use that. But if you want higher rate or lower rate, then it's up to you, and you can calculate the price, and you can say okay, then you can match the current price. Remember the price in the market, price of the bond in the market determined by supply and demand. How many people want to buy that bond and how many are there? But then the price you would like to pay, that's depend on your the rate you are going to use to discount these coupons and redemption amount. So just to be careful, okay? So the price in the market and the price you are calculating using this formula is a little bit different, okay? So when you calculate this way, maybe let's say you get $100, okay? Just for example. Okay. Then in the market, it may be 110. Okay. Then you can say, okay, I'm not going to pay $110 because for my rates, based on my assumption, I would like to, my price would be $100. Okay, so it's dependent on you, but you cannot really change the price. Okay, because you like to pay $100, you can't say the market should lower the price to $100. It's dependent on the supply and demand. Okay, so based on the price you get, then you can decide whether you want to buy it or not. Okay, so just a little bit thinking about that side. Okay. So anyway, so basic price formula says price of the bond should be percent value of coupon plus percent of redemption amount. Now the coupon, how do you calculate coupon? So you have F. What is F? F is face value times the coupon rate. Okay. So face value is F and coupon rate is R. So that's why you will see here FR. Okay. So let me draw the timeline again with the symbol now. And the redemption amount, you will use the C. Okay, so let me draw it here. 0, 1, 2. Okay. So here is the coupon FR, FR, FR. Plus the last one, you have the redemption amount. Now you are discounting. Okay. So you can see right away, this is look like what? It's look like annuity, no? So the present value of this FR coupon payments is FRANJ under the rate J. So if you look at the rate J definition here, the J is the effective yield rate for coupon period. Okay, so J is the effective yield rate for coupon period. Then plus you have CVN because you have discount the redemption amount. This CVN. And V is also 1 plus J. So J is again effective yield rate for coupon period. So this one is called as basic price formula. It is very intuitive. It is very easy to understand. So, and we are using the annuity we learned in previous chapters. So, so in summary, the formula says the price of the bond is equal to the present value of future coupon plus the present value of redemption amount. So that is the basic price formula. So let's do example and see. So Kylie bought a 7-year 5,000 par value bond with an annual coupon rate of 7.6 paid annually. The bond is bought at price to give an investor an annual effective yield rate of 8%. Find the price of the bond. So it's an annual coupon rate, annual bond. Okay, so usually bonds are like semi-annual. I mean the coupon rates, but this one is annual coupon. So it's 7 years. So I have 1, 2, 3, 4, 5, 6, 7. And the coupon rate is 7.6 paid annually. So what's the coupon amount? FR, which is face value is 5,000 times 7.6. So let's calculate this value. What is that? 5,000 times 0.076, which is 380. So every end of every year, you will get $380 as coupon. That the last year, the bond is par value bond. So basically it's 5,000 here. Okay, so this is redemption amount. Then the rate they use discount is 8%. Okay, so when you're discounting, what kind of rate we are using? So V is basically 1 over 1 plus 0.08. Okay, that's the rate they use. Okay. So find the price. Now, if I use the basic price formula, P is what? Present value of coupon plus present value of redemption amount. No? So this would be what? This would be basically, if I write the formula, this is 380 times A, how many, what's the N going to be 7, and the rate J, What's the rate? J is 8%. That's the discount. That's the rate we are going to use. Plus C. C is 5,000 times V to the 7. And what's the V? V is 1 over 1 plus J, and J is 7%. So that's the formula. Now, how do we calculate this? We are going to use calculator. Okay, so in calculator, what you're going to do, you're going to use N equals 7. Compounding per year is 1. Payment per year, because coupons are 1. The payments are going to be 380. The future value, up to now, usually future value either 0 or what is the one we are calculating. But now we are going to set future value at 5,000. And the rate is 8%. Okay, so let's use calculator and see what would be the answer. So let me use the calculator. Second reset, enter. Remember, you are using annuity immediate. Okay, so not a DU. So just be careful there. N is 7, rate is 8%. And let's check. Adjustment is gone. This one is gone. And then payments are 380 because you are going to get is positive. And again, at the end of the 7 year, you are going to get $5,000 positive. And you are calculating percent value. So complete percent value. You have to pay it. Okay, so because you are going to buy. Buying means you have to pay it. You have to, the cash is out of your pocket. So percent value is, what is the answer? 4,095.87. So that's the price of that one. Okay. Let's go next problem. This one says Sam buy an 8-year 5,000 par bond with an annual coupon rate 5%, paid semi-annually. So the bond is purchased to yield 8%, convertible semi-annually. Find the purchase price. Okay, so let me first draw the timeline and then we are going to use calculator. Okay, so here is 0. It's 8-year. But its coupon rate is 5% and the face value is 5,000. So what is the coupon amount? So it's going to be 5,000 times 5%. Divide by 2. Okay, but this is annual coupon rate. Usually coupon rate are given at a nominal rate. Okay, so it's paid semi-annual. So you have to divide by 2. So per 6 months, you are going to get 5,000 times 5% divided by 2. This 125. So here is 0.5. You get 125. This 125. Because every 6 months you get one that coupon. So forth. And then after the end of the eighth year, you will get coupon plus redemption amount, which is 5,000. And the rate used to discount is 8%, but it is given at nominal rate. Okay, so actually J would be 1. For the coupon period, it's 8% divided by 2, which is 4%. So then now let's try to use calculator. So N is how many payments are there? There are actually 16. Remember, N is not year, okay? N is number of payments. So N is 16. Then the rate is 8%, but we have to be careful. It's compounding twice, and the payment also twice. Okay. Then the future value is going to be 5,000, and the payments are 125. And then the rate, the percent value, that's what we want to find. Okay. So again, you use coupon rate to calculate the coupon amount. After that, you don't need this rate. Okay, then you can left it. You don't need it, but you have to keep this 8% in your calculation. So if I want to write the formula, this would be what? This would be 125A 16J. What's the J? J is the effective rate for 6 months. Now in here I get the nominal rate is 8%, compounded semi-annual. So basically, if I use our notation, I2 is 8%. So then the I2 divided by 2, which is for 6 months, is 4%. Okay. So that would be J. So J is actually 4%. Remember, J is effective rate per coupon period. So effective rate per coupon period is 4%. That's 4%. Plus 5,000, V16. What's V? V is 1 over 1.04. Okay, that's if you use formula. But now let's use our calculator. So let me use our calculator. Let me reset it. I usually have to reset. Okay, so otherwise sometimes you will have this memory is not clean properly. So 16 for N, 8 for IOY, second. This one is 2. Compounding per year also 2. Then second quit. And then 5,000 for future value. And payment is 125. And then I would come to 8% 4,126.08. That's the percent. That's the price. Okay. So now you can see this price. Okay, so for the previous problem, the price is less than the redemption amount. What was the redemption of 5,000? No? And here you can see it's 5,000. Price was 4,126.08. When this happens, we will call the bond is bought at discount. If price is less than redemption amount, it's bought at discount. If price is more than the redemption amount, is bought at premium. If they are same, then bought at par. Okay, so when you see the word bought at premium, bought at discount, bought at par, you need to know what's the meaning behind that wording. Okay, so premium mean you are paid more than the redemption amount. Discount mean you paid less than the redemption amount. Then the difference we call as either premium or discount based on which one is bigger. Okay, so if price is bigger than redemption amount, then the P minus is called as the premium. If price is less than the redemption amount, then the difference, this one is called as the discount. Okay, the amount of premium and amount of discount. Let me say. So amount of premium and amount of discount. So here's a problem. This one says consider 30-year bond with an annual coupon rate of 5%, paid semi-annually at a par value of 1,000. So it's 0. It's annual coupon rate. Paid semi-annual. So every 6 months you will get a coupon. The coupon amount is what? The face value is 1,000, and the coupon rate is 5%. You have divided by 2 because it's nominal rate. So that would be 2.5, 25. Okay, so so you'll get coupon amount of $25 every 6 months, and then at the end of the last year, 30th year, you will get the redemption amount, which is 1,000. the bond is purchased to have an annual nominal rate of 5% compound semi-annually. So the rate they use to discount is, let me write the nominal rate is 5%. So when you divide it by 2 for 6-month rate, it is 2.5. That's the rate J they used to, that's the rate for 6 months. Okay. And the redemption value is 12. Oh, now you can see redemption value is 1200. By the way, this one says par value, not a par value bond. Okay. Par value means the face value. If it is par value bond, then it's going to be face value and redemption is going to be same. So it's just par value, okay, not the par value bond. That's why you have different redemption amount. Is this a bond at a premium, at par, or discount? If it bought at premium or discount, find the amount of premium or discount. Okay, so let's first find the price. So you can see N is you have 30 times 2, 60. Payment is 25, and the future value is 1200, and the rate is 5%, but then you compound twice per year, and the payment also twice per year. And then we want to know the percent value. So let's use our calculator and see whether we can get the answer. So can reset. So this one is 60 N 25 for payment, 100 for future value, 500 compute. Second, this one is 2. And then 28% value. So 1045 and 46. That's the price. Now this is less than the redemption amount. Okay. The redemption was 1200. So that means bought at discount. So the discount amount is C minus P, which is 1200 minus 1045 and 46. So find the difference and you can get the answer. Okay, so next we are going to define something called the modified coupon rate. So what is that? When face value and redemption amount are not same, we can define additional parameter, which is called the modified coupon rate. This is defined as FR over C. Okay, so G is modified coupon rate. G is FR over C. Now, if F equals C, then of course you can see G is equal R. Okay, so then there's no point of defining this. So that's why it says if face value and redemption amount are not same, then we can define modified coupon rate. Okay. So using the redemption amount basically. So you can calculate then, if you know the modified coupon rate, then all you have to do is multiply it by the redemption amount and you get the coupon amount. So then you can see coupon amount, you can calculate in two different ways. One is using FR, the other one is G times C. This is useful if F is not equal to C, then this is useful. If you know the G and C instead of F and R, you can calculate the coupon number. Next, we can calculate something. We can define something called the base amount. So let I be the annual effective yield rate. Then effective yield rate J per coupon period is given by this one. Okay. Of course, we can see it easily. 1 plus J to the M equal 1 plus I. So what is M? M is number of coupons per year. And then J is the effective rate per coupon period. And then I is the effective rate per year. Okay. So once you have this, then the base amount is defined using this formula. It is defined by FR over J. Okay, that's called the base amount. Or coupon amount is G times J, which is equal FR. So if you want the timeline wise, let me do the timeline. Zero. This is 1 year. These are coupon payments. And then the effective rate per coupon period is J. Then for the entire year, it's I. So what's the connection? Of course, 1 plus I should be equal what? 1 plus J to the M now. So that's what you have in here. Then you define this nice quantity base amount is FR over J. So here you have FR. So FR divided by J is called as the base amount. So here is an example, an 8-year 3,000 face value bond with 10% semi-annual coupon and redemption value 2,800 is bought at price to give investor an annual effective rate of 12%. Find the base amount and modified coupon rate. So what is the base amount? Base amount is FR divided by J. So what's the coupon amount? It's 3,000. But the coupon amount is 10% divided by 2. So $600. $150. So this will be 150. Then the J is so we have to find the annual effective rate is 12%. Okay, so I is 12%. So I need to find the effective rate per 6 months. This is annual effective rate. Coupons calculated 6 months. So J is basically effective rate per 6 months. And the relationship is 1 plus J square equal 1 plus I. So in this case, 1 plus J square equal, what's the I? I is 12%, so 1.12. And from here you can see J is, let's try to find it, 1.12 to the square, I mean the square root, then minus 1, that would be 0.0582. So now if I use that in here, what's the best amount? I will get close to 2,572.87. So that's the base amount. Modified coupon rate, you can calculate the same way, which is FR divided by C. In this case, modified coupon rate is this one. FR is 150. Redemption amount is what? 2,800. So that would give you the modified coupon. It is 0.05357. Okay, so now we are going to introduce the second formula, premium discount formula. So we start with the basic price formula. So what's the basic price formula? And you have P equal FR ANJ plus CVN. But we know from our previous two formula, base amount and modified coupon rate, we know that FR is C times G, so you can replace FR by CG. So let's do that. And then also you can see that Vn is, I can use the formula for the annuity. So what's the formula for annuity? A and J is what? 1 minus Vn over J. So I can cross multiply. So J times A and J equal 1 minus Vn. And then from here you can see Vn equal 1 minus J times A and J. So I can substitute this in here. So let's do that and then see what we get. So I have CG and J plus C time for V, and I'm going to substitute this formula. So 1 minus J time. So now let's collect the likely term. So you can see, if I write this, I would get CG. Then I would collect those two terms together and take common factors out. So this one is called the premium discount formula. The reason it's called premium discount, if you bring it other side, you will get this nice formula. Now you can tell exactly when you are going to have premium or discount. Okay, so P minus C is positive, which is premium, if what? If G minus J is positive, no? Because C is positive, annuity value is positive, so if G is more than J. So, and then you can see P minus is going to be negative, which is basically discount, if G is less than J. So because of that, you can easily identify when you have premium or discount, and this formula is called as premium discount formula. So that's basically this formula. So here you can find example, 1,000 par value 20-year bond sells P4 and yield and nominal interest rate of 10%. The bond has 9% coupon paper, similar redemption of 12. What is the amount of premium or discount is provided? So let's use since question asking premium or discount, let's use the formula, premium discount formula. So this is C time G minus J A N J. Okay. So what is C? Redemption amount. And what is that? 1200. And then what is G? G is modified coupon rate. What is that? That is basically FR over C. No? So what is F? Face value is 1,000 and rate is 10%, converted 700. So FR is going to be basically 1,000 times 10% divided by 2, which is 50. So this would be 50. And then the C is 1200. So that would give me, so it would be 0.04166. J is effective yield rate per coupon period. So what is the rate? The bond has 9% coupon. Oh, I think I used a different rate. So this yield rate is actually 10%. The coupon is 9%. So I had to actually multiply by 9% here. Oh, so this is not right. So let's multiply. The coupon amount is 1000 times 9% and divide by 2, which is 45. And I had to calculate the modified coupon rate again. So this is 1. So 45 divided by 1200, which is 0.0375. Okay. So now the effective yield rate per coupon period. So the nominal yield rate is 10% because yield 10%, but it's nominal. So effective per 6 months is 10% divided by 2, that is 5%. Okay, so now let's calculate the this quantity. Okay, so let's first calculate C time G minus J. What is that? 1200 times G is 0.0375 minus J is 5%. So 1200 times 0.0375 minus 0.05, and you get negative 15. What is N, by the way? It's 20 year, but you have this N is actually how many payments, no? So it's basically 20 years, 6 months, every 6 months, so it's 40. And J is again 5%. So let's use our calculator. Now, when you want to find this value, you forget about the negative sign here. Just enter it as 15. Okay, so this is look like, so this is negative 15 A 40J. Okay, that's what we want to calculate. So what we do, we forget about the negative sign. We just calculate the 15 A 40J, the annuity for 40 payments under the red J. Okay, with every payment size is 15. So I would enter N is 40. Payment is 15. Rate is 5%. Then the compounding per year is 1. Payment per year is 1. You can enter 10%, but if you do that, then you have to say compounding per year is 2. Payment per year is 2. Okay. Then the future value is 0. Present value. Okay, that's what you. So let's use our calculator. So from reset. So 40 for N, 15 for payment, 0 for future value, 5 for IOY, is 1. Okay. Then 38%. So I get 257.39. So then I come here and then I write the discount because I have to remember that there's a negative sign in front of it. So basically, P minus C is negative 257.39. What that means? That means basically price C was bigger than P. So this is discount. The discount amount, you can forget about the negative sign now. I just say 257.39. Okay, so I'm going to skip the next problem. You can try to do it. Let's go to the base amount formula. So starting with the basic price formula, let's write the basic price formula. So we have price equal FR ANJ plus CVN, where V is 1 over 1 plus J. Okay. So I can use the base amount. If you go to the previous slide, base amount is what? Base amount is basically FR divided by J, no? So I can come here. So using base amount, FR divided by J, which is basically G. Okay. And then also I know that AN annuity in the formula wise, it's looks like this. So let's substitute this into the formula. So what we do, we first come here. We have FR. Then for AN, I would write this formula 1 minus VN over J plus CVN. Then I can see I can write the J in denominator like this. Then I can come back and substitute G in here. This one is G. By the way, CVN, you can leave it as like that. Then you can correct the same term. You can see CVN minus GVN in together plus G. Then from here, you can take the VN as common factor. So you will get the base amount formula. Okay, so here's a example. You can, let's try to do this. A 9-year bond has annual coupon and redemption value of 3,000. So basically, C is 3,000. Annual coupons. It is purchased to yield 9% and each coupon is for 75. So basically FR is 75, yield 9%, so J is 9%. So I can calculate the base amount. G is what? FR over J, which is 75 over 0.09. That would give you, let's calculate. 833.33. Use the base amount formula, calculate the price of bond. So I can calculate the price of bond. P is C minus G, VN plus G. C is 3,000. G is 833.33. VN, how many years? 9 years, and this annual. Okay, so V9 plus G is again 833.33. Then what's V? V is 1 over 1 plus J because it's annual yield. So which is basically 1 over 1.09. So if I use this formula, so I would get 1,830.926. That's the price. Okay, so here is the last formula we are going to use. Again, we can start from the basic price formula. P is FR and J plus CVN. Then the present value of redemption amount, the notation is K. Let me go back to that slide. which you need to memorize. Present value of the redemption amount. The notation is K. Okay. Present value of the redemption amount. So basically what this means, K equals CVN. Why? Because present value. You have this bond 0, somewhere here N, that's C, then you bring it to 0. Vn, this is K. Okay, so K is CVN. Okay. Or present value of redemption amount, not the coupon amount. Okay, just the redemption amount. So let me go back to the last formula. Yes. So I have this notation K is CVN. And then also I know FR is CG. This is a modified coupon rate. Okay, so if you look at the modified coupon rate, FR equals CG. Okay, so I'm using that FR equals CG. So let's substitute, and then also you have A and J equal 1 minus B and now J. So let's substitute all of this. FR is CG. A and J you can write 1 minus B and over J. And the CVN you can just write as K. So you can see, you can write G over J, and then you can multiply everything by C. So C minus CN plus K. But then again, this one you can replace by K. So that is the next formula. Nice thing about this, you really don't need to know the coupon amount. Okay. If you know G and J, then that's good enough. 2500 par value bond with coupon rate 7% payable semi-annually is redeemable after an unspecified number of period for 2005. By the way, yeah, the another thing we still don't need the N. Okay. Number of coupon N has not been given. Okay, so when that is happened, this formula is very nice. The bond is bought to yield 8% converted semi-annually. If the present value of the redemption is this one, find the purchase price. So K is given as what? Present value of redemption amount. Okay, so then what's the redemption amount? C 2500. What's the G? G is basically FR over C. What is F? F is 2500. 7% payable semi-annually. So 7% divided by 2. That's the FR. Then the C is again 2500. So basically G equal R. So basically 7% divided by 2, which is 3.5%. The last term we need here J. So what's the J? J is 8% convertible semi-annual. So 8% divided by 2, which is 4%. So we have everything. Let's calculate the price. G is 0.025, 0.04. C is 2500. And you would get the price. So we don't know how long this bond, like the term of the bond, is it 10 year, 30 year, but we don't need that with this formula. But in order to use it, you need to know the present value of redemption amount. So in a way, basically, still you need to know the, I don't know, somehow, the term of the bond. It's kind of like a hidden, because when you're getting the present value of redemption amount, it's kind of like hidden there. Okay, check that value again. Maybe I made a mistake. Just check it again. Okay, so here you can find several examples. I'll come back to these problems again, but for today, I'm going to stop at this point. So we'll meet again with the examples. Thank you.